Types of chemical reactions. You must have often seen during whitewashing in your house, workers mixing lime, tuna with water. What happens? The mixture becomes hot and steam starts coming out. You must have seen burning coal changing into ash and smoke. You must have seen iron getting rusted. All these are the examples of chemical reactions because some new substances are formed in all of them. So, in a chemical reaction, the substances known as reactants are converted into new substances called products. But are all the chemical reactions same? Or there exist different categories of chemical reactions? In fact, chemical reactions are of different types, and in this module we will learn about them. Different types of chemical reactions are combination reaction, decomposition reaction, displacement reaction, double displacement reaction. Types of chemical reactions. Combination reaction. Let us take a small amount of CaO, calcium oxide, in a beaker and slowly add water to it. CaO reacts vigorously with water to produce slaked lime and releases a large amount of heat. On touching the beaker, you can easily feel that the beaker has become hot. In this reaction, CaO and H2O combine to form a single product, that is CaOH2. Such reactions in which two or more substances combine to form a single substance are called combination reaction. Example of combination reaction is when coal burns in air to form carbon dioxide. In this reaction, two elements, carbon and oxygen, are combining together to form a single compound, carbon dioxide. Another example of combination reaction is the formation of water. Hydrogen burns in oxygen to form water. In this reaction, two elements, hydrogen and oxygen, are combined together to form a single compound, water. Types of chemical reactions. Decomposition reactions. Let us take about 2 grams of FeSO4, ferrous sulfate crystals, in a test tube. Hold it with a test tube holder and heat it over the flame of a burner. What do you observe? Green color of ferrous sulfate crystals changes to white, and then a brown solid is formed, which is ferric oxide, and a colorless gas having the smell of sulfur evolves out of the boiling tube. In fact, the ferrous sulfate crystals, FeSO4, 7H2O, lose water when heated to form anhydrous ferrous sulfate, which is white in color. It then decomposes to ferric oxide, Fe2O3, sulfur dioxide, SO2, and sulfur trioxide, SO3. Such reaction in which a single reactant breaks down to give simpler products are called decomposition reactions. It is important to note that when decomposition reaction is carried out by heating, it is called thermal decomposition. Some other examples of decomposition reaction are when calcium carbonate is heated, it decomposes to give calcium oxide and carbon dioxide. When lead nitrate powder is heated, lead monoxide is formed along with the brown fumes of nitrogen dioxide and colorless oxygen gas. Similarly, when we decompose water using electric current, oxygen gas is collected at the anode and hydrogen gas at the cathode. If silver white chloride is kept under the sun in a china dish, it decomposes to form silver metal and chlorine gas by the action of light. Silver bromide, which is used in black and white photography, also decomposes into silver metal and bromine vapors. Types of chemical reactions. Displacement reaction. Take a few iron nails and clean them by rubbing with sandpaper. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution. What do you observe? After some time, the iron nails become brownish in color and the blue color of copper sulfate solution fades. In fact, in this reaction, iron, which is more reactive than copper, has displaced or removed copper from copper sulfate solution. Such reactions in which a more reactive element displaces less reactive element from the solution are called displacement reactions. Other examples of displacement reactions are when zinc granules are placed in copper sulfate solution, zinc displaces copper from copper sulfate compound and as a result, the copper is set free. The blue color of copper sulfate solution fades due to formation of colorless zinc sulfate. A reddish-brown deposit of copper metal is formed on the zinc granules. This displacement reaction takes place because zinc is more reactive than copper. Types of chemical reactions. Double displacement reaction. Take colorless solution of sodium sulfate in a test tube and add colorless solution of barium chloride to it. What do you observe? Some white-colored insoluble substance is formed. Yes, when sodium sulfate and barium chloride reacts, soluble sodium chloride and insoluble barium sulfate is formed. In this reaction, barium sulfate is formed as a white insoluble solid called precipitate. Here, the exchange of ions takes place. Such reactions in which exchange of ions between the reactants takes place to form 2 new compounds are called double displacement reaction. Other example of double displacement reaction is the reaction of lead nitrate and potassium iodide in which yellow precipitate of lead iodide and soluble potassium nitrate is formed. The insoluble barium sulfate and lead iodide are formed as precipitates. Any reaction in which an insoluble solid called precipitate is formed that separates from the solution is called a precipitation reaction. Types of chemical reactions. Oxidation and reduction. Let us take copper powder in a china dish and heat it. What do you observe? The surface of copper powder gets coated with black copper oxide. As oxygen is added to copper, it is called oxidation reaction. Such reactions where either oxygen is added or hydrogen is removed are called oxidation reactions. Now if we pass hydrogen gas over the heated copper oxide, the black coating on the surface turns brown as oxygen is removed from copper oxide and copper is obtained again. Such a reaction in which either hydrogen is added or oxygen is removed is called reduction. In this reaction, we see that oxidation and reduction take place together. The oxidation and reduction reactions are also called redox reactions. The substance which gains oxygen during a reaction is said to be oxidized, and the substance which gives oxygen or removes hydrogen from oxidation is called an oxidizing agent. The substance that loses oxygen during a reaction or gains hydrogen is said to be reduced, and substance which gives hydrogen or removes oxygen is called a reducing agent. For example, in this reaction, copper 2 oxide is losing oxygen O2 and is being reduced to copper. Hydrogen H2 is gaining oxygen and is being oxidized. As here, one reactant gets oxidized while the other gets reduced during a reaction, therefore it is an example of oxidation-reduction reaction or redox reaction. Types of chemical reactions: exothermic reaction, endothermic reaction. We know that during a reaction, change of energy takes place. On the basis of energy change, chemical reactions are classified into types: exothermic reaction, endothermic reaction. Exothermic reaction. When calcium oxide is mixed with water, a lot of heat is produced. When coal is burnt again, a lot of heat is produced. Similarly, on burning natural gas, a lot of heat is evolved. Such reactions in which heat is evolved and the temperature increases are called exothermic reactions. During respiration, glucose combines with oxygen in the cells of our body to form carbon dioxide and water along with the production of energy. Respiration is an exothermic process because energy is produced during this process. The decomposition of vegetable matter into compost is also an example of exothermic reaction. Endothermic reaction. There are some reactions which take place when energy is supplied to them. For example, when ferrous sulfate is heated, ferric oxide, sulfur dioxide and sulfur trioxide are formed. When electric current is passed through the water, it decomposes to form hydrogen and oxygen gas. Silver chloride breaks up into silver and chlorine in the presence of sunlight. In all these reactions, energy either in the form of heat, electricity or light is required to break the reactants. Such reaction in which energy is absorbed is known as endothermic reaction. Corrosion. You must have observed that iron articles shine when they are in a new state. However, they get coated with a reddish-brown powder when left for some time. Do you know what is this process of coating called? This process is commonly known as rusting of iron. Apart from iron, there are some other metals which get tarnished in this manner. Have you ever noticed the color of the coating formed on copper and silver? When a metal is attacked by substances such as moisture, acids, etc. It is said to be corroded, and this process is called as corrosion. The black coating on silver and the green coating on copper are other examples of corrosion. Corrosion causes damage to car bodies, bridges, iron railings, ships, and to other objects made of metals, especially those of iron. Students, corrosion of iron is a serious problem. Every year, an enormous amount of money is spent to replace damaged iron. Rancidity. Have you ever tasted or smelt the fat or oil-containing food materials which have been left for a long time unused? These fats and oils which have been left for a long time unused get oxidized and become rancid. As a result, their smell and taste also changes. This process is called rancidity. Usually substances which prevent oxidation, also called as antioxidants, are added to foods containing fats and oil. Keeping food in airtight containers also helps in slowing down the process of oxidation. Do you know that chips manufacturers usually flush bags of chips with gases such as nitrogen so as to prevent the chips from getting oxidized?